All right, ladies and gentlemen, sorry that I'm not here today, but this is your right triangle trig 4.1 and 4.3 review and refresher for the quiz that you have today. So the important things to know, the trigonometric functions. Remember that there are 6. So in a right triangle, we've got our right angle, and across from that right angle is always your hypotenuse. The other 2 sides are labeled based on what angle we're talking about. So if I'm talking about this angle right here, remember that's theta, that symbol I just drew. Across from that angle, that side is our opposite. And this third side that touches the angle and isn't the hypotenuse is the adjacent. So once you label all of your sides, you can write out your 6 trigonometric functions. So the sine of angle theta, remember SOHCAHTOA. Can't quite see that, sorry. There we go. Sine is OH, opposite over hypotenuse. Cosine of theta, that's CA, AH, adjacent over hypotenuse. So adjacent. And TOA is for tangent of theta, OA, opposite over adjacent. Remember that you have to have an angle inside each of these trig functions, otherwise it is wrong. Then the other 3 line up directly with sine, cosine, and tangent. Sine lines up with cosecant of theta, and it's just the reciprocal, so hypotenuse over opposite. Cosine lines up with secant, and the secant is the reciprocal of cosine, so it's hypotenuse over adjacent. And tangent lines up with cotangent, and that's just the reciprocal, so that is your adjacent over opposite. And those are your 6 trig functions for right triangle. We also talked about degrees and radians. Remember, degrees and radians are both just ways to measure angles. They mean the same thing, just written a little differently. The conversion to remember for degrees and radians is degrees over 180 equals radians over pi. If you remember that one proportion, you can find any conversion you need. So if I give you 72 degrees and I want to know how many radians that is, I take 72 over 180 equals r over pi. To solve for r, all we have to do is multiply the pi over. And then we just simplify that fraction. So I take my calculator, I type in 72 divided by 180, and then I hit math. The first option is frac, so I press enter. Enter again, that is 2 over 5. Then I add the pi back into the numerator, so it is 2 pi over 5 radians. For 5 pi over 12, well, we want to know degrees over 180 equals 5 pi over 12 over pi. If there's a pi in my number of radians, those pi's cancel each other out, telling me that degrees over 180 equals 5 over 12. Then to solve for degrees is pretty simple. We just multiply that 180 over, and 5 divided by 12 times 180 is 75 degrees. Remember, if your answer is in degrees, you have to label it degrees. Then we also talked about angle of elevation and angle of depression. Just a quick reminder that angle of elevation is from straight out, the angle you would tip your head up to look at something. That is your angle of elevation. Generally speaking, we would have the height of it, how far away you are, right angle there. That's elevation. An angle of depression is from straight out, the angle you would tip your head downward to see something. That's our depression. And for this one, generally speaking, we end up making our triangle down here. And you'll notice that the angle of depression is not actually in your triangle. Remember, we use two different ways to figure out an angle that is in the triangle. We could either know that these two angles make a right angle, and therefore this inner angle is 90 minus theta. Or we can use parallel lines cut by a transversal to know that this lower angle is also the same as theta. That way we have an angle that's actually inside of our triangle to use. Then we can use trig functions to find missing sides. Remember, this is when we use SOHCAHTOA. So we start by labeling our sides. Across from the right angle is my hypotenuse. Across from my labeled angle is the opposite. Third one is the adjacent. I have labels next to A and H, which means I'm going with ka. So that tells me the cosine of my angle, which is 52 degrees, equals adjacent, which is x, over hypotenuse, which is 17. To solve for x, I just multiply the 17 over to the other side. So now I grab my calculator. I'm going to type in 17 times the cosine of 52. The first thing you should do is press mode and double check that you're in degrees. I'm in radians right now. So I go over to degrees, press enter, and now I'm in degree mode. Now I type in 17 times the cosine of 52. My answer is 10.466. X equals 10.466. If there was a label, we would label it, but there's not on this one. For the second one, we do the same thing. Across from the right angle is my hypotenuse. Across from my labeled angle is my opposite. Third side is my adjacent. I now have labels next to O and H, which means I am using sine. So the sine of my angle, which is 63 degrees, equals my opposite, which is 7.4, over my hypotenuse, which is x. When your x is in the denominator, you have to do a little bit more work. You multiply the x over to the other side, giving you x times the sine of 63 degrees equals 7.4. And then to get x alone, we divide by the sine of 63 degrees. So in my calculator, I'm going to type in 7.4 divided by the sine of 63 degrees. I know my calculator is in degree mode because I just checked. So I just type 7.4 divided by sine 63, and I get 8.305. I'd label it if I had labels. Remember to always round to the nearest thousandth place. Next up is coterminal angles. First, we're going to have a definition of coterminal angles. These are angles with the same initial and terminal sides. Remember that these start and end in the same place. They just might go different directions or different numbers of times around the full circle. So if you are working in degrees, to find coterminal angles, you just add or subtract 360 degrees as many times as you need. That's that 360n, because I can do it as many times. If you are in radians, it's the same thing, except that you add or subtract 2 pi as many times as needed. Remember when you are in radians to make sure that you get a common denominator and then add or subtract the 2 pi. Arc length. The arc length formula, we use S for arc length, equals r theta. And remember that r is the radius, and theta is the angle in radians. You have to be in radians for this arc length formula. So if I find the length of an arc with a central angle measuring 108 degrees and a radius of 2.5 inches, I need to start by changing my angle to radians. So remember, 108 over 180 equals r over pi. For our purposes here, we don't need to simplify the 108 over 180, but I will. 108 divided by 180, math, frac, it is 3/5. So my angle, actually I shouldn't call that r, I should call it theta because r is for radius. My angle is 3 pi over 5. So now for my arc length, I take my radius, which is 2.5, times my angle, which is 3 pi over 5, and I just type that in my calculator. 2.5 times 3 times pi divided by 5, 4.712, and my label here is inches. Arc length, a length is just inches. Sector area is also covered on this. The formula for sector area is area equals 1/2 r squared theta. Again, r is the radius. Theta is the angle in radians. So if I find the area of a sector with an angle of 50 degrees and a radius of 1.7 feet, we have to again change our angle into radians. So 50 over 180 equals theta over pi. Multiply my pi over. 50 over 180 simplifies to 5 over 18. So my angle is 5 pi over 18. So to get my area, it equals 1/2 times the radius squared, so 1.7 squared, times my angle, 5 pi over 18. Type that in my calculator. And I get, double check that I typed it in correctly, my area is 1.261. We're measuring in feet this time, but area is in units squared, so feet squared or square feet. And we also talk about the Pythagorean theorem. Remember that the Pythagorean theorem is a squared plus b squared equals c squared, where in any right triangle, a and b are the lengths of the legs, doesn't matter which one's which, but c is the hypotenuse, always across from the right angle, and also always the longest side.